good. Okay, so I think we have everything ready. Yeah. So I would like to welcome you on the, I think it's the 5th Rust Prague Meetup this year. First, I would like to apologize that we have announced this meetup quite late, so that's probably also explains why we have fewer people than usual today. But anyway, thanks for coming. And as always, I would like to thank Martin Dětský, who is helping us organize this and who is making sure that we can be in this great room. And sorry? Yeah. I think he will return in a while. And the Department of Distributed and Dependable Systems. And also Pavel Šimerda, who is organizing this, but he's not here today. So today, as usually, I will have some short intro with some news about what is going on in the Rust project. Then we will see a presentation from our colleague here from Brains and about Rust design patterns. And then I wanted to try something new, something that is called Coding Dojo. And it's actually better for situations when there is only like 5 or 6 people. So it might be good today, but you will need to participate somehow. So we will see how it goes. As I also always give out this link at the beginning, because this is kind of like the homepage of Rust in the Czech Republic. So if you would like to know what is going on in Rust in our country, you can go to the website. There is an RSS feed, so you can subscribe. And I try to put all the events and all the learning materials and recordings, streams, and so on to this website. And what now? So today I would like to talk about Rust edition 2024. Because the year 2024 is coming to its end quite soon, and the next edition of Rust is coming. However, it will actually only come next year, because we won't make it to the end of this calendar year. So here you can see some time plan about what we are planning to do. So if everything goes well, we should be releasing the next edition of Rust in, I hope, February 2025. So it won't be quite 2024, but hopefully it won't be too late. Is there someone who knows how the Rust edition system works? Okay. So I will try to explain the basics, because not everyone raised their hand. So essentially, the edition system is a way how to make backwards incompatible changes in Rust, even though these changes won't break the ecosystem. So essentially, what we do is usually about 3 years, there is a new Rust edition. And in this edition, we can make changes that would otherwise be backwards incompatible. But instead of forcing Rust users to deal with these incompatibilities, we allow them to opt into it. So if they want to use the new features, they need to opt in. Then they will need to resolve probably some backwards incompatible changes. But if they don't opt in, their old code will be still working even in the new edition, right? And all the complicated stuff that handles all these additions is hidden away in the compiler, and the compiler developers need to suffer this pain, but the Rust users don't have to do it, right? So it's kind of a trade-off. And it has been mostly decided that there will be a new edition every 3 years, but it's not set in stone. But currently, this is like the main plan. So probably there will be like a next edition in 2027. And because I just wanted to mention this, that because the editions are one of the few things in Rust that have like a strict deadline. Because normally when we do releases, it's just every 6 weeks, and no one cares what gets into the next release, because another one will be in 6 weeks. So if we miss the next version, no one really cares. It will be in the following one. But the edition is quite different, because if you miss the edition, you might need to wait 3 years before your next feature that might be breaking compatibility gets into Rust. So it is actually quite, I would say, stressful for the volunteers that work on Rust, because they try to get as much done before the edition deadline, but it's not always so easy and even possible sometimes. So what we will have in the next edition? There are 3 priority items in terms of language design. The first one is that the lifetime capture rules will change, and there will actually be a new syntax introduced into Rust for specifying what lifetimes and generic types are you capturing when you use the infiltrate feature on the return type. I know that this might sound quite abstract if you didn't encounter these features. There was actually there was a blog post on the Rust blog about 3 weeks ago that was explaining these changes in detail. So if you would like to know more, I would encourage you to read it. But just in shortness, when you write something like this, currently in Rust, this impl trait, this magical data type that is kind of determined by what you write in the function, it's capturing some life types, it's capturing some generic types, but you don't have a lot of control about what exactly it captures. And the rules of this will change in the next edition, and we will also have this new, where is it? Not yet. This one. We will have this new syntax, use, and in this use statement, you will be essentially able to enumerate all the things that are being captured in this infiltrate return type. Right? So it will be more explicit, as is one of the tenets of Rust, that it tries to be explicit rather than implicit. So this will be something new, but I would say that like 95% of Rust developers won't even need to care about this. Like it's I would say important for some libraries. Maybe you will need it sometimes in your code, but it's not something that you would encounter daily, I would say. But it's quite a big change. So if you're interested, I would encourage you to read the blog post. The second one is that the gen, or gen, I don't know, gen maybe, gen keyword will be, well, it will become a keyword in Rust 2024. And that is it. That's the whole feature. It will just become a keyword. But the cool thing about this is that it will enable generators and asynchronous generators in the language in the future. Right? So first we need to reserve the keyword, and once we have the keyword, it will be possible to actually stabilize the features. Right? So actually, nowadays, yeah, so the keyword is already reserved, but today you can already, yeah, I'm using this new beta of GitHub, and it's kind of buggy. You can already, if you use nightly, you can already use this async gen syntax, and it actually lets you create asynchronous generators with this very easy block, right? So you can do essentially await, and you can do yield inside the generator. So this is like the holy grail of implementing asynchronous iteration, and it's available in nightly, but it was not yet stabilized. And one of the things that we need to stabilize it is to introduce the keyword. So hence edition 2024, and hopefully generators will follow in the next 5 years or something like that. It will take time.
Reserving keywords happens a lot in editions.
Yes. The third thing is this magical sentence that we will make the exclamation mark operator fall back to exclamation mark instead of this unit type. This is super complicated type level thing in Rust. Is there someone who heard about the never type? Yeah, so there is this joke in Rust that the never type is called never because it will be never stabilized. But this is actually a backwards compatibility break that is necessary to stabilize the never type. So possibly in the future, if this happens and it's okay, it will allow us to actually stabilize the never type. And like I would need to make a whole presentation just about this topic to explain what it is, but essentially it would allow you to use the exclamation operator on stable in some locations, and it can have some benefits. But that's the 3 main priorities. And apart from these priorities, we also have some features that are like already implemented, already documented, and there is a high probability that they will make it into the edition. But there is nothing for certain, so it's still possible that these things won't make it, but I hope they will. The first one is that one of the compiler contributors did a great change where essentially, okay, does anyone here use doc test? Do you know what is a doc test? So doc test in Rust is that, for example, that I have some code and I create a documentation comment on top of it, and then I put some code block in Markdown into it, and I write some code. And when I would test this crate containing this documentation test, it will actually compile the code and run the code. So you can write tests in your documentation, and the compiler will make sure that they can still be compiled and that they actually execute without panicking or failing. And this is a great feature, but it had one big issue. Does anyone know what issue this was with the doc tests?
Dependencies?
That's actually, you can use dependencies inside of them, but yeah, it can be a bit annoying to specify the crates, but I think it is actually possible. So that, I don't think that was like a big issue. But the big issue was speed, because essentially what the compiler did before it took the doc test and it compiled it as a separate crate. And if you had 1,000 of doc tests, it compiled 1,000 super tiny crates, and this was taking just so much time. It was so slow. So a lot of people were not using doc tests just because it was slow. And now what the compiler will do, it will take all the doc tests that it can, copy-paste them into one virtual source file, and compile this whole thing as one crate. So it will be like way faster. I have some benchmarks here. Where is it? Yeah, so these are some results from Burnt Sushi. This is one of the very well-known contributors of like Rust crates. He wrote the regular expression crate and a bunch of other crates. And he did some benchmark with before and after this change. Before, he has like 900 doc tests, and before it took almost 13 seconds to run them, and after this change, it took about 250 milliseconds, right? So it's like orders of magnitude faster. So after this change, I hope that doc tests will be like more popular in Rust because they won't be so slow. So that's a cool change. Another change is that these two functions, set and remove environment variable, will become unsafe. So this is actually a pretty big change because like people do use these functions, but unfortunately they're actually not safe, even though they were marked as safe in Rust. And that's because when we change the environment, it's global for the whole process and it's not thread safe. And I don't remember the details, but there is like some interaction with libc or some weird stuff that it was even possible to cause some vulnerabilities or like very nasty stuff. So these functions will become unsafe, and you will need to, or you should specify some command that, yes, I know what I'm doing when I'm setting an environment variable in my own process, because that's quite a weird thing. This lint, unsafe op in unsafe fn, will become 1 by default. So another nice sentence, very hard to understand. This is a lint that essentially, if you have an unsafe function, so something like this, before it was possible to just use unsafe code here. So what is unsafe? Let be as, wow. And now I could do, yeah, something like this or whatever. The thing is that it was, if you just have an unsafe function, it was like implicitly inserting an unsafe block around the code, but now you will need to be explicit about it. Or at least that's my understanding, but it's kind of a small thing, but if you use a lot of unsafe, like gradually it will just become an error. Like you need to be very explicit about your unsafe stuff. Another thing is that this type will implement into iter. I just took it from the release notes, but these are like small library changes, so nothing too special. There will be some unsafe attributes. This is a new thing in Rust that essentially it will become where we can see the RFC. it will become unsafe to use some attributes. So for example, there are some attributes that affect the ABI of your functions or the interaction with C and linking and stuff like that. And now you can just sprinkle them on top of your code and just you hope that it works. But some of them are actually super unsafe to define in your code. So you will need to use the unsafe marker to say that, okay, it is actually unsafe to use this attribute on my code. Right? So again, a small change, but it will be more explicit. Then unsafe extend blocks will be implemented and enabled in 2024. Unsafe extend blocks, I have these tracking issues, but it's better to open the RFC. It's again a useful feature when you interact with C APIs a lot. So you'll be able to say that there is like a block of extern C functions, and it will essentially like flip the default. So it will assume that all of those things are unsafe, but you will have this annotation that you can say that some of the functions are actually safe. So again, thing that you don't need to worry about if you don't interact with C or don't use unsafe, but it will be like a small quality of life improvement otherwise. We will also have some change in the prelude. Does anyone know what is the prelude? Okay, so if you have a hello world program, have you ever tried to run cargo expand on such a program? Actually, I can do it from the IDE. That's simpler. So if you expand a hello world, you will actually see that there are some special things that are inserted by the compiler before main or before the start of your program. We are using the standard library by default, of course, but there is also this prelude thing. And there is essentially a magical import that is added to the beginning of your program, and by default it includes a bunch of stuff from the standard library. So we could even take a look at this module in the documentation, and there are things like vec, string, print line, and so on. You don't need to use imports to write print line, right? It's like automatically imported, and that's yeah, okay, sorry, not print line because that's like a declarative macro, but let's say vec, okay? So if you want to use vec, then vec is imported by this line. And there will be two new things added to this prelude, and that will be future and into future. So if you want to use future in your code, use async. You no longer need to import it. It will be just there by default. So again, a very small quality of life change. Then I have some cargo features will be deprecated, but I don't think anyone uses them anymore. And there will also be some maker changes that I don't really understand, like some fragment specifier thingy. If you write declarative macros, you can check it out, but otherwise I don't think you need to care about it. And then we have a bunch of features that are maybe going to make it. They are either not implemented yet, or they need some testing with Crater or some documentation and so on. The first one is, it's again a very crazy sentence, I'm sorry for that. Rescope temporary lifetimes with respect to else and drop temporaries in tail expressions before local variables. And this very complicated sentence essentially changes the way or the moment where variables are dropped when you use ifs and conditions. And why is it important? Because we need to do this change so that we can stabilize if-let chains and while-let chains. Does anyone know the if-let chain feature? Yes, so if-let chain is essentially a feature in Rust that has been unstable for a very long time. And what it enables you to do is that you can combine patterns in ifs, right? So you can do like if-let something and if-let something else, and you can combine all of these patterns inside one if. Right now you can only use one pattern. But after this change, you could just like nest them into each other. And the good thing about that is that right now, if I want to do like, I don't know, 5 nested pattern matches on one expression, I need to do 5 ifs, right? And this is super this is super annoying because the code just goes to the side. But with if-let chains, I could just have all of them below each other. So this is a very nice ergonomic feature that, yeah, has been unstable for a super long time. And hopefully after this, it will finally be in a place where it could be stabilized. Then there will be some changes to match ergonomics. There are like super long discussions happening about how we can change the theory behind matches so that it happens in a more reasonable way. There are a lot of things in matches that work in a very weird way. If you use like ref mute and references, it will sometimes do some very weird stuff. Again, I will encourage you to check the documentation about the next edition if you want to learn more. But there are probably a lot of changes happening to small match improvements in the future. One change also will be that you will no longer be able to take references to static mute. So you might not even know it, but taking a reference to static mute is like a super dangerous thing, right? Like it's, for example, right? I have like, I don't know, static mute a equals 5. And now I will take a mutable reference. Yes, and there is an unsafe thing, so I can use unsafe, right? I'm very unsafe master here. And just this code already has UB. Like just those 2 lines, it's immediately UB. Because I have 2 mutable references to the same code. And even this is already UB, right? So it's like super easy to cause undefined behavior with global variables, which is like, it's nothing new for us in Rust, but it can be quite surprising. So essentially, this will be denied even inside unsafe. And instead, what you want to do when you use unsafe is use pointers instead of references. And you will be able to do with this new raw annotations. So obviously, this it seems like this IDE doesn't know about them yet. But you can actually, I think it's already in nightly or in beta, maybe even, that you will be able to use this &draw operator to directly take a pointer from something without creating a reference. Because creating references in Rust has like thousands of rules, and if you break just one of them, it's immediate UB, right? So if you use unsafe, you need to take all these rules into mind, and this raw operator will help you.
And then you turn it into a reference with transmute.
Yeah, if you use transmute, then that can be quite dangerous. One thing that will be enabled is this MSRV aware dependency resolver. Does anyone know what is MSRV? So this means minimum supported Rust version. And if you have a project, you can actually specify a version in the cargo toml file. And you can essentially say, this project needs Rust at least 177 so that it can be compiled. And this has been in Rust for, I don't know, like 2 years or something. And in the next edition, Cargo will actually start using these annotations so that it can skip versions that it cannot compile. Right? So if you're compiling with an old compiler and you have some dependencies that you can use, and Cargo chooses one of them, currently it can choose a dependency that cannot be compiled with your old version, and you will just get a compile error. But with this MSRV resolving, if it has like a bunch of dependency versions that it can choose from, it will try to choose the version that is not so new and that it can still be compiled with the version of the compiler that you have. Right? So it will make it a little bit nicer for people that use all the versions of the compiler. Yeah, by the way, if you are creating libraries, I would encourage you to use this attribute to give like information about the users of your library, about what Rust version is needed to compile your code. And then ideally, of course, you should check it on CI, right? That you shouldn't just claim that it is fine on 145 and then you use the latest feature. So that
The Rust toolchain file as well is nice because it will, if you have Rust stuff, it will download the version you need.
Yes, you can create a separate toml file called Rust toolchain, and you can specify like this project needs, I don't know, yesterday's nightly or something like that.
Components of the Rust toolchain.
Yes. And Two last things, there will be a bunch of improvements to Rust format. So you might not know this, but the Rust format tries very hard not to break your code, because if it changed the way your code is formatted every 6 weeks, it would be quite annoying for you, because you would need to change your code after modifying the compiler, because your CI would be screaming at you. So there will be a bunch of changes to formatting in the next edition, because we can do it, it's an edition. And we will also remove implicit cargo feature. I mean, maybe, it's not sure yet if it will happen. But implicit cargo features is this a little bit maybe too implicit thing that if you use optional dependencies and you enable some dependencies in your cargo toml, it will just silently use some. I will show you an example. It's quite hard to explain these things without an example. Sorry. Yeah, so if you have some dependency that is optional, and before the 2024 edition, it would like implicitly create a feature that has the name of this optional dependency, which sometimes was nice that you could enable these optional dependencies directly by their name, but it was a bit implicit, and in some cases it was annoying and didn't do what you expected it to do. So now there is this more like explicit syntax where you say this feature requires a dependency named Giphy, and it doesn't just say Giphy, right? Normally you will just say GIF enables this Giphy dependency, but now you say this dep, like it's more explicit. And you can already do this in like stable Rust, but in 2024 you will need to do it, because it will no longer be possible to write just Giphy here, and that's it. Right? So you can see there are a lot of changes that make Rust more explicit than before. So I think that's quite nice. Okay, so that was it. That were all the changes that I found are going into edition 2024. Is there something that you're especially excited about? Yeah? I'm sorry? Yeah, so Polonius, that's a code name for the next generation of the borrow checker, which has been in development for many years. And it's essentially a next step above non-lexical lifetimes, right? Like we had the original borrow checker, that was great, but it had some issues because it was not accepting valid code. Then we switched to the non-lexical lifetimes borrow checker, which is even better because it uses non-lexical lifetimes, which I won't explain, but it's just better. And then there is a new generation of borrow checking called Polonius that will be even better, like in the sense that it will enable even more programs that are okay, but that don't compile today because the borrow checker thinks that the program is broken. And that most definitely won't make it into edition 2024 because that is very, very, very work in progress. And there are, I think, 2 people working on it right now. And it's one of the Rust project goals, so it's being developed, but it won't make it into the next edition. But I don't think it needs an addition, because it should be backwards compatible. It will just enable more programs to be compiled than before. So I don't think we need to wait for an addition to have a new borrow checker. So that should be fine, I hope.
This Rust version dependency resolver,
Mm-hmm.
how does it choose right version of dependency if I specify minimum version? And the library I'm using, it has to be compiled for different versions of Rust?
So let's say that, I don't know, I depend on dependency in the version, I don't know, 1. Let's say 1. And now I have, and cargo sees that there are version like 1.1, 1.2, 1.3. So right now what cargo would do, it will use the highest version possible. And there is also, I think, unstable flag that allows you to use the lowest version possible. That is sometimes useful for like checking that your library still compiles with the lowest version, but doesn't matter. But what if, let's say that this version bumped the MSRV. So suddenly it uses a new feature and you need a newer version of the compiler. Then when you try to compile this with an old compiler, it will choose 1.3 and you're screwed. It just won't compile, right? But with MSRV aware resolving, it will go through all these versions, and it will find the highest version that still supports your version of the compiler, and of course, that is still compatible with this one. Right? Like it won't go, it cannot break this somewhere requirement, but it will try to select the version that is compatible with your compiler.
But it might be slower if there is many versions and you don't download all the
No, it doesn't. It uses the index. Like it scans the index, and the index is not. I mean, yes, it is slower, definitely. But there are some people right now working on both optimizing Cargo's resolver and also re-implementing it using the pubgraph library. So pubgraph is like an open source project that is like a fast dependency resolver in Rust. And some people are now optimizing pubgraph and making it more compatible with Cargo. And the goal in the future is to use pubgraph as the Cargo's dependency resolver. But that will be a huge amount of work, but hopefully it will happen.
the log file by chosen 1.2 version.
I guess it will ignore the log file in that. I don't actually know. I guess it will try to ignore the log file and use the MSRV compatible version. I don't actually know how it's going to work, but it is documented somewhere. And it's still work in progress, very much.
Will async closures be anything that's expected for time frame 2024 edition?
So async closures are actually quite close to done, I would say, and they are not backwards incompatible. So I think, well, I would say sometime in 2025, maybe in the first half or at the beginning. But I don't think that they are backwards incompatible. So they don't need an addition, as far as I'm aware. But they're already implemented, so everything should be on nightly. Like if you use nightly, I think it should just work. How is it? Something like this. So it will probably need the feature, but other than that, yeah, it should work. And there were still some discussions about how to name the bounds. Like if you want to take async closure, how you should name this type. They are thinking if they should use either this syntax or this syntax. And it has some trade-offs, and I think that they made a decision, but I don't remember which one it was. But I think it's, I think it's mostly done. That it should happen in the next month, and that will be a very nice change because I liked async closures for a long time, and it's just so much pain to try to simulate them with this like async closure returning an async block. Like it usually works, but then you need to send it into a generic function, and it just blows up, and you need to use box and pin and crazy stuff. So, yeah. Okay. Any more comments, questions? Okay. So I think we can switch to the second presentation by Lukáš, and I will just switch the microphone. I don't. So what? So this reminds me. Like, do you mean the HTTP index, or is it something else?
It doesn't download the source code as a dependency, but some binary.
Ah, yes. You mean mir only libs. So yeah, there is an idea that essentially you won't upload the source code to the crates.io, but you will precompile the code into mir, which is the middle level intermediate representation, like something half-baked between your code and the final binary, and then you will compile from it. Yes, that has been an idea for the last 10 years, but no one knows how to do it, especially because mir is super unstable, like it changes every day, And we would need to create some sort of stable mirror. And this has been a project going on for the last 1.5 years, but yeah, it might happen one day, but I wouldn't count on it in the next few years. It's a very complicated problem. Okay.
Hello? Good? Okay. I hope you can hear me and the 2 people that are watching online also. So, funny story. I recently started using Emacs extensively and it became my whole personality. So I made a nice presentation in Emacs. And then I found like a catch-22 where I cannot present if I use my Valent window manager, because on Intel, HDMI doesn't work, and on the dedicated NVIDIA, the window manager doesn't work. So, so I took screenshots of the presentation and stitched it with ImageMagick into a PDF. Enjoy. So, today, I have yesterday's date because I was confused about which day the meetup is. I'll tell you a little about design patterns and Rust. If you want to message me, these are some of the ways that you can do it. I am the corporate whore from Brains that organizes the meetups in the other months. So come, we will definitely make one in October, and we will probably also announce it late, because that's just how it is. So, first question, like a very generic one. What even are design patterns? So the nice description I pulled off from Wikipedia, I think, is that they are reusable solutions to common problems, which is an interesting phrase. I think of them mostly as ways to make programs less messy, or as like established approaches, things that people do all over and over again. They're also a favorite writing topic of Java book authors for some reason. I've seen just so many Java design patterns or design patterns in Java, or trying design patterns in Java for some reason. I don't know. I'm a huge... Yeah, C++ also. But I hate Java, not C++, so we'll, yes, it's enterprise solutions. There is a huge amount of design patterns. This is just a short table of some of them. The 2 that are, or the 3 that are abbreviated are dependency injection, template methods, and on the last line, fluent interface. Also that the intrusive DS are intrusive data structures, which is just a thing that you do in C quite a lot. Not all design patterns are feasible in Rust for one reason or another, which we'll go over. Typically the things that make implementing certain design patterns difficult is ownership, or the memory model in Rust. Sometimes, you know, you can do some design patterns because you have a garbage collector making things really mentally easy. You can do terrible things in theory. For example, the observer pattern is much easier if you don't have a borrow checker. And then also a lot of design patterns, the established ones, hinge on inheritance in one way or another, which we don't really do in Rust. But at one point, Rust used to have classes. So this is a very old Rust snippet of code. Back in the day, I believe this is 2011. It was already a compiler written in Rust that could compile itself, but we still had classes at that point. You know, we even had a private keyword which still exists in Rust, and there is a feature for it. There is a brief keyword feature in the unstable book. But yeah, eventually, a lot of this got removed. This is one commit after they changed the return keyword to return, because it was red before it. So interesting stuff. You can see that the class keyword is not even being highlighted because it's been just so long. If you're curious about that string stuff with the tilde, that's actually a managed pointer is what they called it, and it's a box. This is a string essentially with a capital S nowadays. So there are some patterns that are not that suitable for Rust for one reason or another. These are those, of course. Inheritance as a design pattern, debatable. I think that it is a design pattern. Maybe you don't. But I will not go over through every one of those, but we'll go over some of those. So first, factory pattern, my favorite. Every time I see Java, I see like a type, factory, this, factory, that. With the factory pattern, we are creating objects without specifying the exact class or the exact type of the object. We are encapsulating the instantiation of related classes in one class, that's the factory class, and depending on what input it gets, it will spit an instance of multiple different types, one of those. It is fairly common in Java. That's where I've seen it the most. Personally, maybe I'm wrong, but definitely not in Rust. To do this, you would have to play around with dynamic dispatch with trait objects, but unless you have a really good reason for it, we mostly use static dispatch in Rust. That's what I've seen. Or if you just want to return like a variant of some value, you can just use an enum to tie variants together. So, because this is really common in Java, I'll show you an example of how it's done in Python. So here you have like a class, animal. This is the encompassing one. This is like the interface, the abstract class. Then we have some classes that implement the abstract method. So that would be like the child ones that we are trying to return based on some input. And then we have the factory class that decides the instance which you want to return. So, very easy. In Rust, we can use an enum to tie things together. We have variants for these, and we will return a value variant based on the input we get. Of course, you can attach data to the variants and make it more dynamic. So, inheritance patterns in general, they go against Rust philosophy, where we mostly compose stuff, we don't inherit. Instead of like building up layers one on top of each other, we make like fragments. This would be the traits. We implement the traits, and then when we have generic bounds, we do trait-bounded polymorphism in Rust. We are sticking the fragments together, picking what we need in a given scenario. There is a kind of a form of inheritance in Rust, and that's the super traits, which are sometimes useful for code organization and API design. They also make default trait implementations much easier in some cases, but you shouldn't like be building the classical GUI of I have a widget, I make a button that inherits from widget, I make a colored button that inherits from button. You shouldn't do that sort of stuff. Here is an example of super traits in Rust. We have a drawable trait, which can just draw something. Then we have a clickable trait, and we say that, okay, every type that implements clickable also has to implement drawable. And when that's the case, I can depend on it. So I could make a default trait implementation for the click method and just use the draw method in there. Or if I have a trait bound where I want any type that is clickable, I can call draw because it is implied. Every clickable type must also be drawable. So that's where it's useful. There we go. Also, you can stop me at any point to ask a question. Okay. Now, observer is problematic in Rust due to ownership issues, because very often you would run into situations where you would be handing out mutable references to a single value into multiple places. A great idea to sidestep it in some use cases in Rust is to just do pub/sub with channels. And we really like channels in Rust anyway, so they're always nice. So this is how an observer might look in Python. We have some subject. We can attach and detach observers from it. And when something happens, when we set a new state, we will notify all of the observers and give them access to the state so they can react to it, do something with it, modify it further, whatever. And you know that modify it further part is really not nice in Rust. That we don't like that. There you go. So here we have the concrete types. We have the observer and the concrete observer. And if you use it, it will just be sending messages whenever you call set state. And each of the observers will be able to touch it. In Rust pub/sub, I import a channel. I have some messages that I've defined. Imagine in this scenario that I have like a sensor that can send messages for things like temperature, humidity, or announce that it has been shut down before it actually shut down. So that's what I do. I have a function to read a temperature and to read humidity, and we will send to everyone who is subscribed to the events that happen whenever they do happen. So there we go. Yes, we have like a channel on a different thread, and we are just receiving messages that come from the sensor. If we get the temperature, we print the temperature. If we get humidity, we print whatever the humidity is, and if shut down, shut down. There we go. Okay, so patterns that I have no hard feelings about in terms of Rust. So there is quite a lot. Sadly, once again, we will just be looking at a subset. If you are curious about what is the difference between composition and composite, composite is if you model things as a tree and you have an operation that works on one part, but it also goes down to the nodes and leaves in the tree. So it's something slightly different. All right. Also, fluent interface is like a builder pattern, which we'll talk about, very common in Rust, is a type of a fluent interface, but not all fluent interfaces are builders. So, singleton, ensuring that something only ever has one instance, typically used to keep track of some global state. In Rust, it's a bit goofy because we really don't like global state. We really don't like statics, especially mutable statics, because that's like terribly unsafe. I've seen some comment in one of the issues related to the thing with the unsafe references, where someone suggested, what if we just remove mutable statics completely? Let's just get rid of them. No problem that way. So, but there is still some use for the singleton pattern in Rust. For example, if you have loggers, they will typically be instantiating the subscriber in one way. You want to make sure it only happens once. Or very similarly, because it's a related field with metrics registries. If you use Prometheus, that's what I do with the registry in Prometheus, is I kind of instantiate it that way and just keep it like that. So, once again, big fan of Java, so here is a Lisp example for a singleton. It's not very readable, is it? There is a lot of parentheses. But if you can just imagine that the parentheses are not there, it is actually quite readable. So eLisp itself is not that object-oriented, but it has a Common Lisp compatibility library. And Common Lisp comes with the CLOS, so the Common Lisp object system, and now it is object-oriented. So we are hiding away the single instance that is somewhere, and whenever someone asks for an instance, we are only handing references to that single instance instead of creating a new instance all over and over again. And then if we have methods for that type, we are just affecting that one instance instead of making any more instances. So I'm in each of these statements, I'm requesting a new instance, but it is all the same instance, and when I keep incrementing, it will show. Because if it was different instances, we would have 1, 1, 1. We have 1, 2, 2. All right. So in Rust, we can do a singleton if we do global state correctly. Either we are once, or a mutex, or any of the other libraries. There's a lot of very nice libraries for doing global variables in Rust and keeping track of global state. I like static dynamic the most because it's just super ergonomic and it can do actual life before main. And it's very fast. But probably you likely use one cell or a lazy static. So here I'm implementing my singleton. I'm taking a look at the value, incrementing it, and if someone asks for the value, I'm just taking a look at it. And when someone asks for an instance, I have two statics hidden here, a nasty mutable one, but we could absolutely do this without the mut static. I just wanted an excuse to include the unsafe keyword somewhere in the presentation. You can do this without unsafe Rust, absolutely, don't worry about it. Here, we are instantiating a global option with a mutex. And whenever someone wants a reference, we return a static reference to that one instance that we have hidden away that no one else can access it because it's in the scope of the function. Okay, good. So the decorator pattern. You have seen decorators in Python quite a lot, which is related. We are adding new behavior or modifying behavior without actually altering the underlying object, so we are decorating it. In Rust, this is fairly uncommon as opposed to some other languages. Some of the things that you would use decorators for, we could probably model with new types. And the way that I see the difference between the Rust new type and the decorator in Rust is that decorators I feel are generic. If we have a concrete type in there, it's a new type. So here another Python example. I have a class called coffee. It has some cost and some description. And then I have a milk decorator, which adds milk to something. Naturally, if I add milk to something, it has to become more expensive. And it will also be really nice to mention that there is milk in there. And what I can do is I can take coffee, I can wrap it in the milk decorator, and it still has the same API, but it now behaves differently. We are using the coffee as basis, and we are modifying it with the milk, decorating it. It's the best example I could think of that would fit in a short scope. Here's how you can do the exact same thing in Rust. So this time I am creating a trade coffee. I have a unit struct called simple coffee. Same methods, nothing really different. Then I have a milk decorator, which is a generic struct that wraps around whatever a coffee is, whatever type that implements coffee. And I am calling the trade methods from the inner type and modifying their result. And it works pretty much the exact same way. There we go. So I can once again request stuff, and I would see that it's multiplied, modified. Yeah, there we go. I also have a sugar, I forgot to mention, I also have a sugar decorator here. So there is a couple of patterns that are very common in Rust, or also fairly encouraged, of course, the composition approach to OOP. But then we have, for example, new type or RAII, which is something, and a couple others. So RAI, as I like to call it, RAII, resource acquisition is initialization. That's a very good name, isn't it? I've seen some discussions about just the name. Like, you tell, I'm going to use resource acquisition is initialization. Like, yeah, sure, buddy. That sounds great. But I'm not sure what would be a better name. So I guess what we are doing is that we are tying resources to object lifetime. So a resource is automatically acquired when the object is created, and when the object is deleted, the resource is released. And the resource can be anything. In the context of Rust, we are mostly talking about memory. You know, when you make a box, it makes an allocation. When the box goes out of scope, it deallocates. But it can also be files, which is also what happens in Rust. If a file goes out of scope, it will be flushed and closed. Same thing with socket. Most of the discussion about this pattern is in C++, but it is very popular in Rust. In C++, shared pointer, unique pointer are the memory thing that I mentioned with box. Actually, shared pointer is like arg, unique pointer is like box. So here is an example in C++. I want to make a file class called sobor that will actually follow this pattern. So as uninteresting write method, but what is interesting is that when I am creating an instance of the class, I will immediately open the file, and in the destructor, I will close the file. So that's the pattern. Pretty simple, I think. It's better looking at an example than hearing the name, I believe. So this is how I use it. Fairly simple, no problem. File will be automatically closed when it goes out of scope. That's it. So in Rust, we have resource acquisition is initialization almost everywhere. And it comes very naturally with Rust memory model, since you almost never deallocate manually. So imagine something slightly more interesting than opening files. There is a very nice game development library, maybe even graphics library called Raylib, after the creator, Ray. So nothing with ray tracing. No. This is the guy is called Ray, so it's his name. And it has a lot of methods. It's a C library. You have a method for initializing a window. You have another one for closing a window. And in Rust, we could use resource acquisition is initialization to use the handle, because Raylib has a handle that you have to keep track of. And if we make an instance, we will initialize the window. If it goes out of scope, we will clean up. We will call the close window. And there will be a ton of other functions below it. So I'll make a Raylib handle for myself, maybe keep track of the width and height, whatever else, plenty of stuff. This is minimal example. And when I am implementing it in the new associated function, I will call the init window, and then I will implement drop. And in the drop, I will call close window. And so now I know that the library is initialized when I have a handle around, and when I drop it, I know that it will clean up properly. Pretty easy. Oops, there we go. Wrong button. There we go. Builder pattern. So builder lets us construct complex objects with a simple API in essentially step by step. There is two good reasons why we use builders a lot in Rust. The first one is that we have no default parameters. So if you require a lot of configuration for an object, it makes sense to have some defaults, but you cannot do that in Rust. And imagine if you have like a new method that takes 15 parameters, because that's all the things that could possibly be configured. That's not nice. One way that you could tackle it is by, okay, I will not have 15 parameters, I'll just take a config structure that has 15 fields, and you have the same problem. How do you configure that structure? And also, you may have multiple of some arguments. For example, if you have a process, you can be passing in the arguments one by one. There is actually a method called arc on std process command, which does exactly that. And we just don't have variadic functions in Rust. So it's nice to do this. And essentially what you're doing is you make methods that configure one particular part of an underlying object on a builder structure, and then you either pass a mutable reference as a return value or you pass self. I've seen both happen quite often. So here we have a pizza. You can configure dough, sauce, and toppings. And then we have a pizza builder that internally keeps track of the pizza it is building. Of course, new method, not that interesting, but we have one method for each of the configurables, dough, the sauce, and then we have a method called add topping, because maybe you want to just add a lot of toppings at once, like arguments to a process. And that's what we do. In this case, I'm just returning self. And finally, we have a build function, which will just return the instance. Now, there is cases where you want to use builder, but you have some parameters that are actually mandatory. And there is some really nice grades. I think one of them is called static builder, which does very fun generic magic to give you this really nice builder API, but also force you to configure in any order the required fields. It's really cool, but the errors are terrible when you screw it up. Because you see, I expected this thing that will implement this, this, and this, and you just have a massive tuple of bullshit in there as a generic parameter. So there you go. And this is the builder. This is the nice API that we are trying to create. Very, very common in Rust. And finally, yes? New is like a convention. Yes. Yes. Pizza implements default, which will just use the default value for everything, so that will be an empty string. But that's like a fine default value for initialized data, but it may not be a valid value for the rest of the program, right? Like, for example, if you have a phone number and the default of an integer is 0, it's like it's a valid value for the type, but it's a valid value for the primitive type, but it does not make sense for the big type that I'm building. So you hide the fields away and you configure them via the builder. So you can ensure that there are actually values that are sensible and that you can then depend on it. That helps you.
Yeah, can you go to the next slide?
This one? Yeah. Second structure, the builder, that keeps default pizza inside. You have methods to configure each of the fields. And then you finally have a build, which will consume the builder and return the inner pizza. Should have called it a pizza oven, that would have been fun. But not that much sense, like imagine just putting your hand to the fire to put one more slice of bacon. So yeah, this is the nice API that you are trying to make. There we go. So new type is a very rusty pattern. So it was originally introduced in Haskell, I believe. You're wrapping one type with another type and then implementing extra functionality for the type. You need it quite often in Rust because of the orphaning rules. Essentially, if I am in crate A and I depend on crate B and crate C, I cannot implement trait from crate A on a type from crate C. I cannot do this like between dependencies. And the reason is very simple. It's because there is like no tangible link that would make a direct dependency between me and the other two. And the behavior of the program would change if you just edit my crate into the dependency graph, because suddenly there would now be an impl in my crate, even though it's not related to either of those. So those rules are called orphaning rules, and if you were to do that, that would be an orphan instance. So what we want to do is create a tangible link to my crate. So I wrap it in a unit structure that just wraps over, or tuple of one structure that just wraps over the inner value and either proxies it or doesn't, depends. And when you are using it to add trait implementations, like let's say here I have a hash map, and let's assume that hash map cannot be serialized in Serial. It can, but let's assume that it cannot be, or maybe that I want to serialize it differently in a better way. So I wrap it in a type that looks almost exactly the same in terms of the generic parameters, and it just wraps over it. So I have hash map but cooler, and now I can implement serialize for hash map but cooler, and have a definitely cooler implementation of serialize where I just call the inner one, but you could do a lot of stuff with that. I could not implement serialize for hash map because neither serialized nor hash map is from my crate. So that would be the issue. There would be like no tangible link to me, and just including me as a dependency would change the behavior of the types involved, because suddenly now there would be an implementation clause that wasn't there before. Yes. And sometimes people use new types to just add methods to stuff. I'm not sure if it should still be called new type at that point, but in that case, it's kind of an alternative to extension traits, I think, which is this. It's a convention. There have been a couple extension traits in the standard library. There was a ASCII extension trait for strings. I believe it has been deprecated since. Not sure if there are any others, but extension traits exist. Typically, extension trait has the name of some type, ext, or maybe you can make an extension trait for a trait. So you would have like trait ext. You add a method in there, then you implement it, and if the trait is in scope, then you can use it. So now if I had a string, I would just be able to do my string dot is palindrome, and it would look just like a normal method. So that's like, it's an extension. All right, so this has been kind of like a quick overlook around some patterns. There exists a book, online book, Rust book, Rust design patterns. Just put it into Google, you'll be able to find it. It's an MD book that has examples of fun and unfun patterns and some other great advice to structure Rust code properly. And I believe that's it. I have like 5 minutes for questions before I have to run to catch a train, literally. Oh. If not, then that's even better for me.
Which patterns do you use the most at brains, or maybe in your day-to-day?
I just really like making builders. That's everywhere.
Do you implement manually, or do you use derived crates?
I use the derived crates quite often, but sometimes I do it manually. If I actually want to have like some extra validation in the methods and be able to refuse some values, then I do it manually. But if I just want to have like a nice API for what is fairly straightforward instantiation, I use, and I believe it's called static builder, because it does the nice thing where you can mark things as optional or required, and if you don't instantiate all the required stuff in any order, that's really nice, is that you can do it in any order. Then it will throw a compile time error. Nice. Yes?
Is new type pattern also valid for avoiding primitive obsession?
Primitive obsession?
Yeah, it's like relying on primitive types like ints or strings
Yes. Yeah, I'm not sure if I would still call it new type, but in a like same syntax, you have a tuple struct of one element. It wraps just a single primitive type. What we use it for is, for example, units. We have a crate that's just units in brains, and we have stuff like volts, hertz, and then you have operations on that make sense for those units. So yeah, absolutely. I'm not sure if I would still call it new type, but that's something that you can absolutely do and make sense to do. All right, I guess that's it. Thank you.
I can just show maybe some of the things that we mentioned, just so that we can see an example. So if you literally Google Rust design patterns, you should find this. Yeah, as Lukáš said, it's an online book. So there are a bunch of patterns that you can use. Okay, bye Lukáš. So there are a bunch of patterns, and some of them are like the classical ones, like the OOP, gang of four stuff, like behavioral, creational, structural, and some of them are more like general things that you would do in Rust. So I think it's quite nice to examine this website. And yeah, so Lukáš was also mentioning some crates. So I don't actually know which one he uses, but I will show the ones that I use. This crate is called Derive Builder, and it essentially allows you to create a struct and then put this thing on top of it, and it will automatically generate a new struct that is called Lorem Builder, and it will have like methods for configuring all the attributes of this struct. And you can say that the methods will receive self by value or by reference, and you can do like validations and stuff. So this is quite nice for tests. The annoying thing is that sometimes you want to have like a structure that is like a domain thing in your main logic, and then you want to have like and you don't want to annotate that with derive builder, so you need like a second struct that is like this buildable thing, and then you derive builder and you get a third struct that is the builder. So it can be sometimes a bit verbose in code, but it's quite nice. And the second thing that I think Lukáš was mentioning is, I think it's called typed builder, but this is not that great. Type builder or something like that. Yeah, so there are multiple builder crates, and some of them, I think it's also this one, it actually can give you like a compile error if you forget to set some of the required attributes, right? Like normally the previous crate, it will just panic at runtime if you forget something, but there are also crates that like model all the initialized fields inside of their generic parameters, so it generates like 50 structs with all the permutations of things that can be initialized. And then it gives you a compile error if you forget something. So that's like an interesting trade-off, and you can sometimes use like the compile error stuff, sometimes the thing that is panics at runtime, depending on what are your trade-offs. And one more thing about builders that I wanted to mention is because a few days ago there were some new RFCs opened. Yeah, this one and this one. So the first RFC is that if it's accepted and implemented, you will be able to implement derive on enums and set the default attribute even on variants that have fields. That is not possible today. So that's just like a small thing. But the bigger feature that is, it's still an RFC, so maybe it won't happen. But some people are proposing that we use this new syntax where you will be able to essentially give a default variable for a field in line in the struct definition, right? So this would make it much easier to create default values of some structures, and together with some new or like a helper syntax that would be added to this, it could essentially implement default parameter values for functions. Like it will be quite different than, for example, in Python or other languages. But if those functions, if those features were implemented, I think it would be much nicer in Rust to actually do default parameters, which is today, yeah, it is not really possible. And I don't actually need it usually in my code, but in the tests, I just want it so much because in tests you configure so many things all over again, and you need a lot of parameters. And without the defaults, you just need to create the builders in tests. And so with this new feature that maybe will happen, no one knows yet, it's an RFC, it would be much nicer. Okay, so now the last thing on our agenda today was the coding dojo. But I actually got even another idea before that for like 2 minutes. I want to make a brainstorming session with you because because you're here, so I want to use you, essentially. I am a leader of the Rust survey team, and we are currently preparing the next edition of the Rust survey. Is there someone who filled the annual Rust survey last year? Yay, 1, 2, 3. Okay, thank you for your contributions to our survey efforts. So we have a survey each year that we send out to the Rust world. It has been filled by, I think, 13,000 people last year, so quite a lot of people. And we are doing one every year. And we have a bunch of questions, and we are changing those questions to improve them. And because you are a sample of Rust community, I want to ask you for your opinion about one question. So where is it? Yes. So we have this question that sucked last year because it was just wrong. It was just asking the wrong thing, and there are like stupid answers and so on. So I'm trying to improve this question. And essentially, what we want to ask you, the Rust community, is what are some aspects of Rust that you struggle with, that you have some issues, like some things that you code in Rust and you find some like very general aspect that is problematic for you. We would like to know about these. So for example, we have things like I cannot easily split things across crates because of the orphan rule. Or I have to do iterator implementation manually because generators are not stabilized. Or I cannot implement plugins because we don't have a stable ABI, right? So things like that. So I would like to ask you if you have any other ideas, like what we could add to this prepared list. Like, can you think of some like general aspect or area of Rust that you struggle with when you implement something in Rust? Mm-hmm. Sorry?
Code readability.
Okay, code readability. Okay. Do you think that we could do something like? Do you think that Rust could change in a way that that the code becomes more readable, or is it more like just a general issue of people writing unreadable code?
Just use forward types.
What types?
Forward types like in PowerShell or Bash.
Okay.
But that's fine.
Okay, so that's not a feature that I'm really familiar with, but okay, we could. So we actually also have another question that like literally lists some unstable and missing features, and you are supposed to vote like what is your favorite feature that you want to get stabilized. And this is more like a general area, like what do you find annoying on Rust? Uh-huh.
I would say sometimes refactoring.
Okay.
If you have some trade-offs that you need to add or remove, you need to do it on many places.
Mm-hmm.
I mean, because Rush is kind of verbose, but when you need to refactor it, sometimes it's a bad.
Okay. There is. I think. Do you think that trait aliases would help with that? So, trait alias.
I haven't read it.
Okay, so trait alias is essentially that you would be able to say this, that like I have some alias for a combination of traits, and now if you would like to remove this default, you don't need to go through 50 places in your code and remove default everywhere. You would just change it here in the alias, and you will be using this alias name everywhere. So
More, I had a problem with, let's say, adding lifetimes.
okay.
Or if I decided to change a string reference to string, or the other way around, changing a string to string reference,
Mm-hmm.
the reference needs to have a lifetime, so the struct needs to have a lifetime. That
Yes.
we didn't have before, and that means changes on many parts of the code.
Yeah, I agree that that's annoying. That for like Rust Rover has very powerful refactoring capabilities, but even like adding lifetimes is not really something that is easy to do. So that's, yeah, I agree. Okay, any other ideas what we could add to the list?
I don't remember it exactly, but I had some issues with passing function in traits. We will somehow solve, so it is some kind of work in progress, but
Yes, so you can use async functions in traits now, but you cannot specify bounds. So for example, you cannot say that the function, that the future needs to implement send, which is a very common use case. And yes, this is very well known, and it will hopefully be added soon, but soon can be like a year. So yeah, so I have some stuff. Okay, so expressing bounds on asynchronous in traits.
generally here using custom code.
Yes, I had this as a point like literally last year it just said async, like the answer was async, but I think it's better to like separate it into these more concrete use cases to okay.
And what every new developer asks in Rust is why so many strings.
So okay, so
Representation of string,
so choosing the right string type. Okay.
but just one string as any other languages.
Yeah. Well, yes, because the world. Yeah. That's a good point. Okay, so we will try to modify this a bit, and we'll see what happens. So let's quit the survey. Okay, so the last point of the program today, what I prepared is something called a coding dojo. Did someone ever hear about coding dojo, like what it is, or did anyone participate in a coding dojo? Okay, so we have one person here, so at least you can cooperate with me. So I have the idea written here. So the idea is that a bunch of people in the same room will code together some simple application, and the idea is essentially to have fun, but try to share ideas or tips and tricks that you might know, and also learn from others. Right, so we set up some simple goal, like for example, we want to implement some simple application, and then we take turns coding on a single computer, and everyone else just like looks at what the person is doing, and we can give them like hints or what they should implement or how and stuff like that. And when you are coding, you can share some tips and tricks, like for example, if you know some cool cargo subcommand or a library method or a dependency that can make the code better, you can use it and show it to others, or others can suggest some new thing for you to use, and you learn new stuff. Does it make sense? At least a little bit? Okay, I mean, the worst case that can, I would time block it at 30 minutes, so half an hour. And the worst that can happen if no one wants to participate, I will be just live coding. So that's like the worst thing that could happen. But what should ideally happen is that there will be one person writing code, another one who is like the co-pilot, so they'll be like standing here and telling him what to do or giving some suggestions. And then after a few minutes, we will rotate and someone new will come and become the co-pilot, and the co-pilot will become the driver. So,
Why not approach the connected code
I mean, I don't think that everyone here has a laptop, and I think it's better if people just come here and code here. Like that. I can like switch keyboard layouts and do VS Code if you don't like IntelliJ. We can configure it. So anyone, and yes, and the goal that I prepared is to implement a simple assembly interpreter, like super simple. Just take a bunch of instructions, take a simulated CPU, execute those instructions, and we probably won't have time for it, but we can do like parsing of the program from string and so on. And I have some sub-goals prepared, like easy stuff, medium stuff, hard stuff. We probably won't go through even half of it, but I can then put it into a Git repository, and for example, like on the next meetup, we can continue with it, or if you think it's boring, we can just forget it ever happened. It's up to you. Right? It will be like super simple, right? I say assembly interpreter, but it is literally like I have an array of bytes and I have an instruction add to numbers, and I just get the numbers, I add them and put them back into the array, right? That's it. So like nothing special. So anyone wants to participate? Someone else? I mean, you are participating by sitting silently and staring at the screen, of course, but... Okay, so let's start with you, and then maybe... Yeah, so you are the only one that raised their hand, so... So I will put the README here, so that we see the goalpost, and... Yeah, so I don't have two chairs, sorry. So I will start as the driver. Okay, or you can take the chair. I will start as the driver, and we can like discuss what to code, and then we can switch, or we can just sit here for half an hour. So I will try to time box it, and so we end at like 8 p.m. Okay, so what do we need to make a CPU? So
I would make a struct of CPU.
Okay, sounds good.
And with it, some memory, which would be...
No, it's like the AI does it for us. I need to turn this thing off.
Okay.
Yeah, that's better. Okay, so we will need some memory, okay.
Let's say 256 bytes.
Okay.
We would need some registers. Let's say, okay, 16.
It implements everything for us. I need to turn this thing off. I literally said don't use AI, and now it's using AI for me.
Okay.
I would like to show one trick. Sometimes when I do these like live coding things and I want to get interactive feedback, I like to use a thing that is called Cargo Watch. Does anyone know Cargo Watch? You just need to get...
I guess it should compile every time you
yes.
or something like that.
Exactly. So you do Cargo Watch build, and now every time I make a change in the source code, it will rerun build. So I don't need to even click on anything. I don't need to think about it. I just Alt-tab, and I see immediately the result. Right? So it is actually not built into Cargo, but it can be downloaded with Cargo install cargo-watch. Okay.
Okay, so I would allow that code, first of all.
You would what?
For the whole project, I would allow that code.
Okay.
To get rid of this warning, because...
Yes, that is a good idea.
During the development, it's always painful, let's say.
So this is an attribute for the whole crate that allows that code lint, so now no warnings. And yes. I would just make a change already here, because I don't like reading initialized memory. So I actually have it, well, yeah, I don't have it somewhere here later, but I wouldn't model it as a U8, but I would model it as something that is either initialized or uninitialized. What do you think?
Okay.
And now, if someone reads from memory that wasn't written before, they just get crap. They get they get this thing. So we won't have the problem with like an instruction that reads memory that wasn't. Yeah.
Okay. I would just let our CPU to be zero initialized on default. And
Man, that's boring. That's boring.
Okay. Okay.
We need some errors in it.
Okay. I think we need to assign some registers a special meaning. Especially, we need a special one of those 16 registers to be program counter.
Okay.
And maybe some stack pointer. That is not necessary.
I don't think we'll get to a stack, to be
Okay.
honest. Yes, so we already have the first point finished.
Oh, great.
Good. By the way, if you have any suggestions, just scream them at us. You can say whatever you do. So I have this second thing here to implement an instruction to move stuff from one place to another. So
Yes,
Good.
I think we would need some way to interpret bytes from memory cell into some kind of instructions, instruction decoder, let's say. Let's say we have a enum of instructions.
okay, sounds good.
Yes, we will have a move instruction with two parameters, let's say, register index and register index.
Okay. So we can move from one register to another. That makes sense.
Yeah.
And
Register
how to?
index can be struct of tuple, let's say u size.
Okay, or u size.
Yeah.
Okay.
And we need for that enum we need a way to initialize it from a memory cell. So either we need to have a method.
I would maybe suggest just having a vector of instructions so that we don't spend half an hour
Okay.
parsing the bytes of the memory into instructions. So I would just create a vec of instructions, to be
Okay.
honest, so that it's a bit easier. Okay, so let's create some instructions.
Oh, you don't want to have instructions in the memory.
No, I don't think we could do this
we
in
would
this
be
time.
Two separate memories, one for instructions and one for data. Okay.
Yeah. It will be like
That is much simpler.
it will be like a Harvard architecture. So we will have a memory for instructions, memory for data.
Okay, so
I guess-
no von Neumann.
Yeah, and we can create I guess we can create the CPU.
Yes.
And why not default, I guess.
Yes.
So let's implement default. And now we need to implement default for the memory cell. So we need to do this. And I think what we need to do is say this. Yeah, you need to, if you implement default on an enum, you need to select the variant that will be used as the default variant. And yes, this.
You need to implement copy also for that.
Yes, this. We could actually take a look at the error. It doesn't implement default for the cell, but hopefully this will help us. Will it? No, it seems like it doesn't work even with copy. So we probably will have to do it manually. That's a bit annoying. Well,
Okay.
anyway, doesn't really matter. We
I
can
thought
just.
there was this thing long ago that you didn't have a default for arrays longer than 32, and I guess it should have been resolved with const generics.
I don't remember, to be honest. But I know that this works, so
Yeah.
I will probably just write it like this.
Uh-huh.
And this looks good. So yeah, it compiles again. And I actually think we have time to switch. So do you want Czech or English keyboard?
English.
Okay, so you have English. Are you okay with Rust Rover?
I have no idea.
Okay.
Never used it, but I think I will be okay.
You can try it. Okay.
Yeah.
Does anyone want to become the speaker, the driver?
Copilot?
Copilot? Sorry, copilot. No? Okay, so I guess we will just wait.
Okay, so what do I need to do?
So we have the second one is done. We have the move instruction, and now we need to execute it. So I would suggest to create a function that will take a CPU and an instruction, and it will just execute it.
Okay, I would do one thing. I would say that instructions should be here.
Instruction. Could be, yeah, why not? Maybe later I would put them inside like a program structure, but for now they can be inside the CPU, no problem.
Or, okay, whatever. So you need a implement for CPU. And let's say function run.
Mm-hmm.
Or maybe if you want, we can put instructions outside and put it.
Yeah, I can maybe like just execute one instruction and then we can write the loop to go through all the instructions.
Okay. Let's say we will have something like this here.
Mm-hmm. Yep.
Execute one instruction.
Mm. Sounds good.
And I guess instruction is copy, is it?
It's not, but I don't think it matters. I mean,
Okay.
it can be like this.
Okay, then I will take the reference.
Yeah, why not?
So we'll match
Mm-hmm.
instruction.
And you can actually this is always what happens when I go from VS Code to it's Alt Enter.
Alt enter. Okay.
Alt Enter. So this will generate.
Okay.
It's instead of Control dot, it's Alt Enter. So that's the only change.
Okay.
So the first is the
Destination or source?
destination. It's like an x80.
Mm-hmm.
It's an Intel. If someone knows assembly in Intel syntax, it's destination and then source, or at least I hope so.
So we will just move. Oh, this is registers.
Yes, this is registers, and later we might need to generalize it so that you can also put memory there. Because right now you can only use
Yes.
registers. So.
Yes. I would just do a load and store instructions for moving from memory to registers and then move between the registers.
Okay, so yeah, we could do like a RISC CPU.
I mean,
why not?
we have only 30 minutes. You know?
Yeah.
So, I guess something like this. Self-register.
Yeah.
What did you say?
Top. Now it's just top.
Yes. And yeah, that's it.
Yeah, I guess that's it.
Yes.
And one thing that we have here is that we have the new type for the register index. Register index. So what I would do normally probably is that now you could use register index to index into memory, but that is wrong, right? Because that's so what we could do is create some wrapper for the array and then only allow it to be indexed that like the memory array can only be indexed by memory index and the register array can only be indexed by register index, but that will take like 10 minutes, so
Okay.
let's just skip it, I guess.
Yes. So I think that's it.
Actually,
Yes,
I
this
think,
is nonsensical now.
yeah, I think we have a problem there that if the source is uninitialized, we should return some error, right? Because you would be essentially reading uninitialized memory.
Okay.
So let's define some error, some enum error type that we will return.
Okay, I would maybe
Yes.
maybe
Put it into
take a
more
crate
files.
of anyhow, let's say.
Okay.
Something like this.
Mm-hmm. And just click on this one so that it reloads, and it will see the crate.
Great. And I don't need this
Yeah.
now. And I usually do this thing that I say, pub type,
Mm-hmm.
just to make things,
Yeah.
let's say, less verbose. So I will return this thing
Mm-hmm.
that will automatically fail the whole program,
Yeah.
but I need to not fail in here. I didn't call it, so this needs to be mutable, and then I could say CPU run instructions.
Mm-hmm. And then just loop over them and
Yes. Yes, I also need to return here and here.
mm-hmm. Yeah, good old for loop. Nothing new needed.
Like this.
Yeah. And we'll need probably the question mark operator to propagate the errors.
Yes. Okay, so
So
here,
here I think.
yes, that also. And here we will say if register at the source. If
Yeah, so maybe we could create like a method on the enum or do this. Yeah.
so something like this.
Yeah. And do you like to, is there someone here who uses anyhow? And do you prefer to use anyhow bail, or do you prefer to just use like anyhow the macro? Bail, okay. Mhm. I mean, to be honest, I don't think so, because during the implementation, like you could do anyhow in 10 different ways, and the author of anyhow chose, like he had like 10 different axes, and for each thing he chose like one solution, and he hard-coded it into the crate, right? Like the way it is stored in memory, the way it stores the inner error, the way you iterate over the sub-errors, and like whole other things. I don't know, to be honest. I wouldn't. I don't think it will happen, but maybe someone will do it. But I don't think you could do it fully generically. And I mean, to be honest, even std error is not finished yet, and it took like 10 years. So, like the error trait got into core a few releases back, but there are still some stuff that is not done. So I don't know. But one thing, so sorry, why I mentioned it, one thing I don't like about bail is that you don't see the control flow, that you don't see the return before it. So I usually just spell it out, like return, anyhow, blah, blah, blah. Because when I have bail and I scan the function, I don't see the return. So I don't see that there is some control flow in it. So that's just like my personal preference.
I think if you want to use a standard library, you still have this thing. I mean, that's basically the same thing, except for some, like...
Except for all the useful stuff.
Yes, yes. Okay.
Like context and stuff like that, yeah,
Yeah.
that is very useful.
Yeah, yeah. And also, the backtrace of anyhow is also very useful.
Yes. That's something I struggle with, like if I just use this error, or I have like the enum variants of error, it's super nice that I can just match over it and I see exactly what happened. But when it fails like nested in 10 functions, I don't see where the error happened because there is no backtrace by default. So I need to go modify my code at the backtrace, see where it failed, then debug it, and then remove the backtrace because you don't want to have it inside the enum. You want to have it as small as possible. So I would like to personally have something between this error and anyhow, so that you have like the enum, but you also have the backtrace, but you can turn the backtrace off whenever you want. So that's something that I would appreciate.
Okay, so I will.
Oh, is there some specific feature? I don't think I ever used any features of.
Backtrace.
It's not the default?
I don't think so.
No? Okay.
What is wrong with me?
Equals.
Equals.
Yeah, there is actually you have this Rust backtrace environment variable that controls the backtrace of the panics, and then you have Rust -lib -backtrace, and that controls whether anyhow is creating backtraces on every error. So yeah, that can be a bit expensive if you do that every time an error is returned from a function, but yeah. I think it misses the OK at the end of the function.
Okay.
And the same one in run.
Is there a way to run the fermenter?
Yeah, it should be done automatically, I think, but
I have a VS Code to format a code every time I press save.
yeah, it also happens here. It just needed to be enabled, so it's now.
Okay. So.
Okay, so we can execute the instruction. We have some errors.
So now, if I say cargo run.
Yeah, it ran. I mean, we don't print anything or anything like that. We could maybe add a print instruction or set.
I would expect it to fail because we have uninitialized memory.
That is a very good point.
This thing.
Yes, and that was actually the warning. Why it was showing this warning that we are not handling the error.
Aha.
Right, so this result is marked as
here.
must use, and if you mark something, a function, a type as must use, if you don't use it, the compiler will complain. And that's exactly for these situations, that we had some error and we didn't handle it. We were confused, like why is it not showing an error? And this was the case.
Okay, so now I get a backtrace if I need to debug where the thing happened.
Yeah, this is pretty nice that anyhow is actually creating the backtrace, so that's...
Although I don't...
Or actually this is maybe...
Execute one on line 22.
Yeah.
So
And yeah, so you see exactly where the error was created.
although you need to dig a archaeology thing to see which
Yes.
of these texts are the relevant for you.
The ID actually tries to auto-hide the standard lib stuff so that you only see your code, but in the terminal there's nothing like that. So maybe we could add an instruction to actually set some data to a constant so that we can actually do something else than move uninitialized stuff around. Just U8, I guess. Like set a register to U8, and then maybe print so that we can print it.
I would just print the whole memory at the end.
Okay, why not? I wanted to try how we could test the print instruction, which could be interesting, but we can also test print everything, so it's fine.
Okay. So to print it, I would say
and Alt-Enter will create the method for you.
Alt-Enter, great.
Yeah. It still cannot find the right impl block even after I was even trying to fix this, but then they made the plugin closed source, so I failed to do it, and they still haven't fixed it, but it's a bit annoying.
I would just do,
Yeah, sure, why not?
or maybe even this thing. And I need to derive.
Yeah, derive debug so that we can format the structure. And the same, you need to do it on the memory cell. Or actually, maybe I did it before. I don't remember. Yeah, I did it before. Okay, so it's fine.
So setting, let's say we don't want to fail, so we will set first the register 1 to some value.
It's an index, register index. It's missing.
Okay. And now it shouldn't compile because this is non-exhaustive. Yes.
Yes.
Alt enter.
Alt enter, exactly. The second one, yeah.
Okay. So this is also a destination, and this is value. We will.
AI knows what to do.
Yes, but
Sometimes.
knows it wrong. I guess this way.
Yeah, I think it needs to be the memory cell. So maybe we could implement like from. I think we could implement like from U8 for memory cell, so that when you have an U8, you can turn it into an initialized memory cell. I guess that makes sense.
Okay, so we will want to do this thing then.
Yeah, into.
And we will need to implement.
From. Yeah, it knows. And you can actually go and do Alt Enter and it will implement the thing.
Okay. And we just return.
Self-initialized.
Yes.
Yes.
This thing.
This thing. Right. So if you have like this simple abstraction and you need to just create it easily from some inner value, you can implement from, and then you can use into on the value. And maybe you could then have like a generic code that just takes into memory cell, and you could put anything you want there.
Okay, so we will try it. What
Yeah.
will happen? I'm not sure whether it even compiles. It doesn't seem to compile.
Oh yes, because it's a reference.
It's a reference, and I cannot call into on reference. I mean,
No, because we have implemented from U8, but we haven't implemented from a reference to U8. So there is this help thing,
yes.
and actually, if you try to, this is I hope it will work. We can try it, but if you try to compile it in the IntelliJ IDE, it shows you the error. And if there is a machine applicable help, you can actually click on apply fix, and it will directly apply the fix into the source code. So you don't even need to write it out. So this is pretty cool when it works.
Yes, yes. I was just confused because usually it will add references on a dot calling method.
Yes, but in this case, it's a bit different. Like it's because this from it's on value, so it won't automatically dereference the reference. It would work in the opposite direction in some cases, but yeah, it's better to have the right type.
But I mean, if I had this thing, it will dereference CPU for me to code run. So that is why I was expecting into also to dereference things, but okay, maybe.
But it goes from value to reference, right? And here we needed to go from reference to value.
Okay, yeah.
So that was also a bit different.
Yeah. I would maybe do this ugly thing.
Yeah, why not?
Why not? Because it's ugly, but not in my business logic, but it's ugly somewhere else.
Yeah.
So now I can or maybe The thing that I don't understand yet how it works. Can I just comment it this way? Or I will just delete it. Maybe if I put a ref keyword here, maybe that would work? Or deref? Or
In this position, yes. Yeah, it depends on when is the pattern. Like if it was like a for loop, we would put a reference before the name of the variable to like unwrap it. Yeah, you can try it. Does it work? Or doesn't?
apply?
No, it seems like it doesn't. So this is one of the things that the edition 2024 I think will be trying to improve, because it's just so confusing, like how are references propagated through match statements. Like there's so many rules and special cases and stuff that happens inside. I never remember it. I just always try it until it compiles.
I would like this thing to work.
Yes, but you cannot do it here because it's a different place than when you have, for example, a for loop. It's like a different rule is being applied to the pattern.
Okay.
But yeah, this works. So
Okay, so now we should see. Yes, now we have
Yay.
two registers which have the new value.
so we have, after half an hour, we have successfully set the value 42 to 2 items in an array.
Yes, so I guess that's it.
I guess that's it. I don't want to sit here for an hour and go through all these things. But what I think we could do is actually save this code, and I have still a lot of stuff, like, for example, we could parse the instructions from a string and create some error messages and stuff like that. So maybe we could keep it for the next time and just again try the coding dojo and continue and do, because this was like the very basics, right? Like the initialization of the project. We saw some, I think, interesting stuff, but maybe when we do more complicated things, we will see even more interesting stuff. So I think I can put it to GitHub, to some repository, even with this like plan. And we can either continue next time, or you can, if you want, you can try to implement it at home, I guess. So does anyone have any, like, thank you very much for cooperating with me. I know that we didn't do a lot in those 40 minutes, but you know, when you initialize the thing, there is a lot of stuff that needs to be done. But is there something interesting or something that you didn't know, or that you want to ask about or comment or suggest something that could be done in a better way? Which, yeah, you mean this thing? Yes. So this is essentially, I think it's called like binding mode or something like that in patterns. And let me demonstrate it on something. So yeah, sorry, I need to switch to check. I actually called on check. Message. Yeah, so imagine that you have a value of this message, and you want to do like a match statement. You want to inspect what is inside of the message. So you do this. But the issue is that when you write this, you essentially move message. You consume it. So you cannot do this. You cannot do this twice because it will be. How did this compile? Why is this? Because yeah. Because this is another crazy thing in the patterns, that when you have this underscore, it's like this underscore in patterns is magical. It is something different that if you have, for example, only this is just like unused binding. But when there is just the underscore, it's just magical. Let's stop at that. So when I had it like this, it was just ignored. But when I actually take the pattern, it will be moved. And it gives me this hint that I should use this ref thing. And so how to inspect this message without moving it? So first solution is that I can match on the reference of the message. So I take like reference to the whole message, And then this A will automatically, everything that is inside the match will automatically be a reference, essentially, right? So this compiles. Or if I wanted to only selectively take some of the things as references and the rest as moves, I could specify this ref thing, and this essentially says like bind this value into this pattern, but take it as a reference, right? Like in a way, it's the opposite of the ampersand. Like with the ampersand, you create a reference, and with the ref, you sort of like unwrap a reference in the binding. Yeah, I cannot say that I could explain it in a much better way. I would need to prepare some talk about it or something. But this is not always the same. So for example, if I had something like this, then this X binding is a reference to I32. And sometimes I would need to actually get the value, right? So I need to send it to some function that needs the value. So I would need to use this dereference. And the opposite of this dereference in the binding is the ampersand operator, which is quite confusing. So instead of this dereference, I could do this in the binding. So this is like the same thing, but achieved in the binding mode. So yeah, the match ergonomics, like, it won't break your program, it won't cause UB or anything, but it can be a bit confusing sometimes, so people are trying to improve, like to unify the rules so that it's more intuitive and works as you would expect. But I don't use ref very often. I think, like, yeah, okay, inside the match statement sometimes it's useful, but I don't think it's something that you would like spam 50 times a day. I don't know, depends. Any other questions? Okay, so I will put it online and post it on Discord if anyone would like to play with it. And I owe you a code for IntelliJ ID. And otherwise, I guess that's it for today. So does anyone have any questions, comments, do you want to discuss something? Would anyone like to continue into a pop? Yeah. Okay. Anyone else? Yeah, not today. It's usually we have like a critical mass of people, but today the critical mass is hard to achieve. Anyway, bye bye to our streaming audience. I will stop the stream now.